Hi friends, in this very lesson, we're going to be solving the second question we are given as a take-home in our previous lesson on balancing complex redox equation. In our previous lesson, we solved this very question already in acidic, medium or format. But in today's lesson, we're going to be solving this or balancing this very equation in alkaline medium. So let's quickly look at this. What do we have right on the board? We are asked to balance Hg plus NO3 minus plus Cl minus equals to HgCl4 2 minus plus NO2 in both acidic and alkaline media. So we're done with balancing this very question in acidic medium, I beg your pardon. So we're going to be doing that in alkaline medium this time around. So let's quickly look at that. Don't forget that. First of all, we're going to be getting the oxidation numbers of both reactant and product. So Hg here plus NO3 minus Cl minus equals to HgCl42 minus plus NO2. So the mercury is 0, oxidation number, oxygen minus 2, nitrogen is plus 5, chlorine is minus 1, chlorine here is minus 1. So if chlorine here is minus 1, it means mercury here minus 1 times 4 is minus 4. We send it to the other side. Mercury is plus 2, oxygen here minus 2, nitrogen here is plus 4. So quickly, let's see our reduction and oxidation. Now, look at the mercury from 0 down to plus 2. This is absolute oxidation. Increment in oxidation number is oxidation. Now, for the nitrogen, from plus 5 oxidation number down to minus 4. Clearly, this is reduction, RED. So when you look at other players like oxygen here minus 2, oxygen here minus 2, there's no change in oxygen. Chlorine is minus 1, chlorine here is minus 1. So oxygen and chlorine are not the major players in this very equation. So the major players are Hg, mercury, and nitrogen atom. So first of all, you're going to be looking at the oxidation. It's quite straightforward. So Hg down to HgCl. So when you look at this, the mercury atoms, I beg your pardon, are the major players, but chlorine also played a major role here. If not for the 4 atoms of chlorine here, there will not be mercury having plus 2 oxidation number. So it means you're going to be considering the chlorine here also. So we have Hg here plus Cl aqueous equals to HgCl4 2 minus. Don't forget that the major focus is on the mercury atoms. This is 0, this is plus 2. But we can also balance out the chlorine atoms. We have 4 atoms of chlorine here, and here just 1 atom, we add 4 to this place, and we have a chlorine atom balanced out. So we have our chlorine atom here balanced out. So what are we going to do next? Quickly, let's look at the electron exchange. Don't forget the 0 here. So yeah, plus 2, it means 2 was added to this. Don't forget. So how do we do that? We're going to do that by using electron to explain this. So that'll be Hg here, then plus, since it's addition, we're going to be subtracting 2 electrons from it, minus 2 electron plus 4Cl equals to HgCl4 2 minus. So don't forget 0 minus 2 times minus 1. 0 plus 2 will give us plus 2. So we're done with the oxidation. So this is equation 1. So the next thing we're going to be looking at now will be the reduction. So let's quickly look at the reduction. NO3 minus gives us NO2, with no charge, just 0. So NO3 minus, then giving us an NO2 with no charge on the product N. So this is plus 5, don't forget, the 2 major players, plus 5 and plus 4 for the other nitrogen atom. So how did they arrive at this very junction? Minus 1 was attached to this. So 1 was subtracted from this 5 to give us plus 4. So don't forget that when you look at the atoms of nitrogen here, they are both balanced. So nitrogen, 1 atom, oxygen here, 3 atoms, oxygen here, 2 atoms. And the oxygen is what complicates this whole reaction. So quickly, NO3 minus, then how do we subtract one oxidation number? We're going to be doing that by adding 1 electron to this. So this NO2. So we have this set down already. So nitrogen, 1 atom, 3 atoms of oxygen, 2 atoms of oxygen. Don't forget that we're talking about reduction right now under the alkaline medium. This reduction under the alkaline medium. So how do we balance reduction under alkaline medium? Don't forget, for reduction under alkaline medium, we're going to be adding water to the reactant, then hydroxyl ion plus water to the product. So we're going to be doing that right away. NO3 minus plus H2O, then plus this electron equals to NO2 plus OH minus hydroxyl ion, then plus H2O, the water molecule. So quickly, we're going to be using the algebraic method to balance this up. So quickly, let's do that. So this A here, this B here, this is C here. I'm going to be leaving this out. So quickly, let's use the algebraic method. So the nitrogen, you have one atom of nitrogen, one times A is A. So no other atom of nitrogen on the reactant. So for the product, we have one atom of nitrogen, one times C is C. So you have A equals to C. So we're done with that, no other nitrogen. So oxygen, the next atom. So you have three atoms of oxygen, 3 times A is 3A. Then oxygen, one atom plus B, then equals to oxygen here, two atoms, 2 times C is 2C for oxygen. Then oxygen here is two atoms, 2 here. So that's fine. So we're done with oxygen. So the next is hydrogen, the last atom of element. So 2 times B is 2B for the hydrogen equals to the product. Hydrogen is 3 atoms on the product end. So quickly we're done with that. So we're going to solve all this simultaneously. So 2B equals to 3. So if 2B is equal to 3, it means B is 3 over 2. So that's what B is. So if B is 3 over 2, can quickly fix it in to get our A. So 3A plus 3 over 2 equals to 2C. Since A is equal to C, it means 2C is 2A also. 2A plus 2. Collect like terms to send this to the other side. 3A minus 2A equals to 2 minus 3 over 2. 3A minus 2A is A. So if you cross multiply this to solve this off, you end up having 1 over 2. So A is 1 over 2. If A is equal to C, it means C is 1 over 2 also, while B is 3 over 2. So we're going to bring all those coefficients and fix them right into this place to balance up the setup. So A is 1 over 2, that'll be 1 over 2 times NO3 minus plus B is 3 over 2, 3 over 2 times H2O, plus this electron out here, that equals to, the C is 1 over 2, 1 over 2 times NO2 plus the OH minus plus H2O. So what do we do? The LCM of the denominators, 2, 2, 2 is 2. So we're going to be using a coefficient of 2 to multiply all through both the reactant and the product. So that'll be times 2, times 2. You don't have any business with this electron, times 2, then times 2. So 2 takes out 2, 2 takes out 2, 2 takes out 2. So you have everything well set out. So what do we have? What we have is, I'm going to write this right here. So we have NO3 minus plus 3 molecules of water, 3H2O. Then what do we have next? The next thing we have is plus electron. That was well set out. Then we have the NO2 here, just NO2. Then we have these two can share out on them. We have 2 hydroxyl plus 2 water molecules. So this is well spelled out. So this is it. This spelled out already. We're done with this for the REDOX reduction under the alkaline medium. Nitrogen, one atom. Nitrogen, one atom on the product end. Don't forget. So one atom, one atom. Oxygen, 3 atoms plus 3 atoms, 6 atoms. Oxygen, 2 here plus 2, 4 plus another 2, 6. Hydrogen, 6 atoms. Hydrogen here, 2 here plus 4 here, 6 atoms also of hydrogen. So we are going to be taking off this very portion so that we can just bring this together and finish up everything here. So after finishing everything with oxidation and reduction, so we're going to be solving this using elimination method. This two, we're going to be solving this simultaneously. So when you look at the oxidation, we have 2 electrons here. When you look at the reduction, we have 1 electron. I beg your pardon. So how do we make them balance? How do we balance them out? We're going to times this with 1, then we're going to multiply this with 2. So we're going to be doing that right away. So 1 multiplies all this, 2 multiplies all this just to balance out the electrons. So 1 times all this will give us Hg minus 2 electron plus 4 chlorine atoms. Iron, so that'll be Hg Cl4 2 minus We're done with that. So the next 2 multiplies all this bunch. So that will be 2 NO3 minus plus 2 times that will give us 6 water molecules, then plus 2 electron to give us 2 NO2, then plus 2 multiplies all this, that's 4 hydroxyl plus 4 water molecules. So let's bring them all together. Let's finish up what you know what we started. So this 2 electrons and 2 electrons. So minus plus, it takes out each other out. We're going to be adding them together. This is addition. Yeah, adding them together. So we're going to add up all the reactant and also add up all the products. So let's do that right away. This Hg plus 4Cl minus, then plus 2NO3H, that's minus, then plus 6 water molecules equals to addition of all this also, that's Hg Cl42 minus, then plus 2NO2 plus 4 hydroxyl ion and plus 4 water molecules. So we balance this, about 99%. So what are we going to do next? We have 6 molecules of water here and 4 molecules of water. So what we're going to do next is the molecules of water 4 can cross over to this place. That will be 6 molecules of water minus 4 molecules of water. That will be 2 molecules of water. So every other thing is balanced out. We have Hg4Cl minus plus 2NO3 plus 2H2O equals to HgCl42 minus plus 2NO2 plus 4OH. And that is how to balance this in alkaline medium. So we're done with everything on redox equation, both the simple or the non, when we talk about simple, we're talking about redox equation in neutral medium, and both the ones in complex states, that is the ones either in acidic or alkaline medium. So we're done. So we've come to the end of everything on redox. In the next lesson, we're going to be looking at mole concept. So you gain 1 or 2 things from this very lesson. I'd love you to give me a follow at Revelation Up on Facebook and also subscribe to this very channel at Eddie Mosaic. And please share this lesson also with others. See you in the next lesson. Thanks and bye for now.